Last week, we had the continuation or the introduction of the quadratic equation and how to solve them. In fact, you were able to solve quadratic equation into 4 different ways. So this time, we will still have quadratic equation and rational algebraic equations. So meaning we'll still have to apply what we have learned last week. So let's start with an example. Example number 1. Solve the rational equation x squared plus 3 all over 3x equals 19 over 12. So to solve a rational algebraic equation, we must always rewrite the equation first and then multiply both sides of the equation by the LCD or the least common denominator. I know you are all familiar with LCD since elementary we have been working with fraction. And by the way, when we say rational equation, these are equations that can be written in fraction form, wherein the numerator and denominator are polynomials. Meaning to say, there's a variable found in the numerator or in the denominator. So let's multiply this both sides by the LCD. Our denominators are 12 and 3x. So we're going to look for the LCD of these two. The LCD of 3 and 12 is 12. And since we have x here, the LCD now becomes 12x. And you'll multiply this 12x on both sides of the equation. So let's do that by distributing this expression on the left side of the equation is considered one term. If you will multiply it this one, x will be cancelled from the denominator. 12 divided by 3 becomes 4. Okay? Do the same thing to the right side of the equation. Multiply 19 over 12 by 12 over x. So instead of multiplying 19 by 12x, you can divide 12x by 12 as what we did on the left side of the equation. So 12 can be cancelled and you now have x times 19. So therefore, we have here 4 times x squared plus 3 and 19 times x. And then next, we have to distribute this so that we can remove now the parentheses, simplify both the left and the right side of the equation. So 4 times x squared is 4x squared. 4 times 3 is 12. Copy the equal sign. 19 times x is 19x. And as you can see from this part here, we already have the quadratic equation, but it is not in the standard form yet. So therefore, we will transform the quadratic equation to the standard form to solve for its roots. So with that, we'll now have 4x squared minus 19x plus 12 equals 0. From this equation, we applied addition property of equality, or we just simply transpose 19x to the left side of the equation. Hence, we have 4x squared minus 19x plus 12 equals 0. Next, since we have the standard form of the quadratic equation, we can now solve this using factoring or extracting the square root, computing the square, or the quadratic formula. If you do not know how to factor, you can always use the quadratic formula, okay? But in this case, our given can be factored out. It is factorable, so I'm going to factor it. But like what I've said, if you do not know how to use factoring, you can always go back to by using the quadratic formula. So we'll factor 4x squared minus 19x plus 12 equals 0, and we'll have 4x minus 3 times x times the quantity x minus 4. If you will multiply 4x to 4x, you'll have 4x squared. And then 3 times negative 4 is positive 12. If you will add negative 3x and negative 16x, That is equal to negative 19x. So the factor of 4x squared minus 19x plus 12 equals 0 is the quantity 4x minus 3 times quantity x minus 4 equals 0. And then apply ZPP just like what we did last week. When we say ZPP, making each of the factors equal to 0. So if we have 4x minus 3 equals 0 here, the other one would be x minus 4 equals 0. Then we transpose 3, divide both sides by 4, and the value of x is 3/4. On the other side, x is equal to 4. So this is the answer to this rational equation, x squared plus 3 over 3x equals 19 over 12. Next, another example. Solve the rational equation x plus 8 over x minus 2 equals 1 plus 4x all over x minus 2. Again, rewrite the equation and look for the LCD of the denominators. Since we only have x minus 2 as our denominator, then we can multiply both sides by x minus 2. Okay? So we'll have this. X minus 2 times x is x times the quantity x minus 2. I did not proceed by multiplying them right away. I just simply write them as this. So to avoid confusion. Then x minus 2 multiplied by 8 over x minus 2, this will be cancelled. That's why you only have 8. Equals sign 1 times x minus 2, you'll have x minus 2. And then 4x over x minus 2, again, this can be cancelled, giving you positive 4x. Then simplify the left side of the equation since we still have the quantities, the parentheses here. Distribute x. X times x is x squared. X times negative 2 is negative 2x. Copy plus 8 equals x plus 4x is 5x. Copy negative 2. And then, since you can notice the highest exponent now is 2, we can now transform this to the standard form of the quadratic equation by simply transposing all of the terms on the right side to the left side of the equation. So we'll transpose 5x and we'll transpose negative 2 to the right side. So from positive, it is now negative, and then from negative 2 to positive 2. Then we'll have to combine like terms in this equation. So we'll have now negative x squared, copy x squared, negative 2x minus 5x is negative 7x. 8 plus 2 is 10 equals 0. This is now the standard form of the quadratic equation. Again, you can solve this by using factoring or quadratic formula. The equation again can be factored out. If you do not know how to factor, you can always use the quadratic formula. And the factored form is x minus 5 times the quantity x minus 2 equals 0. Use or apply ZPP by making both factors equals to 0. So we have x minus 5 equals 0 and x minus 2 equals 0. And the value or the roots are x equals 5 and x equals 2. Let's now have the word problem. The width of a bedroom floor is 5 meters less than its length, and its area is 84 meters squared. Find its dimensions. When we say dimension, it is the width and the length. So therefore, since this is a bedroom floor, we conclude that the shape mentioned here is a rectangle. So let us proceed solving the problem. Let W be the width of the bedroom floor. Let L be the length of the bedroom floor. Now, according to the statement above, the width of the bedroom floor is 5 meters less than its length. So therefore, the width is represented now by W. 5 meters less than its length. Length is L. So it can be translated to as L minus 5. Okay? And it says that the area is 84 meters squared. Now, like what I've said a while ago, that we have concluded that this is a rectangular bedroom floor. And the area for solving the formula for solving the area of a rectangle, we use length times width. So using this equation, we are now going to substitute the details above. Okay? So what is the area? It says 84. So using this equation, substitute the information found here. So 84 is the area. The length is represented by L, and W is represented by L minus 5. So this is length times width. Okay? Next, multiply or simplify the right side of the equation. L times L is L squared. L times negative 5 is negative 5L. We now have a quadratic equation. Transform this to the standard form of the quadratic equation by simply transposing 84 to the right side of the equation. That's why you have negative 84 here now. Okay? And then this equation can still be factored out. And right, what I keep on reminding you that if you do not know how to factor, always proceed by using the quadratic formula, which is x is equals to negative b plus minus or square root of b squared minus 4ac all over 2a. Since we know how to factor, we will use factoring. And L squared minus 5L minus 84 is equal to the factor of the quantity L minus 12, L plus 7. Apply ZPP, you'll have L minus 12 equals 0, and the other one would be L plus 7 equals 0. Apply the addition property or transpose negative 12, you'll have L equals 7. Apply the addition property also on this equation, and you'll have L is equal to 7. So we have now L, which represents the length of the bedroom floor, which is 12 and negative 7. We will not consider negative 7 as the measurement of the length of the bedroom floor. Why? Because we are talking about measurements. And since it is the dimension of the width and length, there is no negative measurement involved for this. That is why we will only take positive 12. Since L is 12 meters, we can now find the value of the width by simply substituting 12 to this equation. So we will substitute it to WL minus 5 to find the width of the bedroom floor. So replace L with 12. So 12 minus 5, the width is 7 meters. Okay? 12 minus 5 is 7 meters. So the dimension of the bedroom floor is 12 meters and 7 meters. So that is all about solving rational algebraic equations involving quadratic equation. Hope you have learned something about this topic, and hope you'll find it easy to answer the given tasks and activities to you. Okay, bye. See you next time.